Okay, I'm going to be doing answer keys as videos for each part of the review packet. So I'll start with number 1, and hopefully these will be helpful for when you're working on that test and fixing your review packet. So the first thing is they will give you a word problem here. So it's talking about an independent movie theater selling children and adult tickets, and they'll tell you how much was sold. However, this equation here is going to be the important part. You won't have to make this, they'll give this to you. So this is really the equation you're working with the whole time. And then this little blurb after here tells you what x and y represent. So we want to identify that. So it does say that x equals the number of children tickets. And it tells us that y equals the number of adult tickets. So that's step 1. That's going to help us with our graph later on, and also hopefully help us with labeling our answers. So we know that there's 2 types of intercepts. There's going to be our x-intercept and our y-intercept. So the cool thing about x-intercepts is that we remember that x-intercepts are when y equals 0, and a y-intercept is when x equals 0. So we can actually go ahead and plug that information into the equation for both of these to get what our x and y intercepts are. So if I take the equation 6x plus 9y equals 36, 6x plus 9, but now it's not going to be y, it's going to be 0 because we know y equals 0 for this intercept. So it'll be equal to 36. And the nice things about intercepts is this term cancels out because we know 9 times 0 is 0. So we're just left with 6x equals 36. So we could go ahead and solve that one-step equation by dividing both sides by 6. So then we are able to determine that x equals 6, because 36 divided by 6 is 6. So this will be 6. And then when we label it, we know that x represents children's tickets. So it's 6 children's. So that will be our label here on our x-intercept. So then we go for our y-intercept, we're doing the same exact thing, but we're plugging in, instead of now plugging in for x, or so for y, we're plugging in for x. So instead of 6 times x, it'll be 6 times 0 plus 9y equals 36. Again, this term here cancels out, so we're looking just for the y term. So we get 9y equals 36. And then when we go ahead and divide both sides by 9, we do get that y equals 4. And we know again that y is represent the adult ticket, so when you go ahead and label that, it'll be 4 adult tickets. So that's how you're going to do part A here. And then this, the important part here, we're going to use these 2 pieces of information, a little off there, to help us graph part B. So when we're graphing part B, the first thing we want to do is label our x and y axis. So we know the x-axis is the children's tickets, and the y-axis is going to be our adult tickets. And then when we go ahead and number these, we're only going up to, I believe, 6 and 4. So you can label these by ones. So we can go 1, 2, 3, 4, 5, 6. We'll go 6 both ways. 1, 2, 3, 4, 5, 6. And again, like if we're numbering them, I know we just did ones where we were counting by different numbers, but this is where we're just counting by ones. So you don't have to put all these numbers on here, but I'm going to just show you that that's what I'm counting by. Okay, and remember that intercepts are where it hits the x and y axis. So when I go to graph it, if x equals 6, on the x-axis, that's where we're going to put our first dot. And then our y-axis, y equals 4. So I'll put my dot on 4. And then if you remember from graphing, all you need to graph an equation is 2 points. So now that we have these 2 points here, we can draw the line through them. And that will be our graph for this. So let's say we make this lines, and we'll make it a little bit bigger so you can see. So that will be our line. It goes through the x-axis at 6 and the y-axis at 4. So that will be how we do part B. And then for part C, it's saying give 3 possibilities for the number of tickets that could have been purchased by the customer. So for this problem, you're just looking for 3 different points on the line. So we know we already have 2 points because that's what we use to graph. So this point here is going to be over 6 and up 0. So 6, 0 is a point. Another point we have in the graph is the one we plotted over here. So that's 0, 4. And if you remember, you have to find the 3rd point on the line. So I will be very lenient here because I know it's not the easiest to find points on the Kami graphs, but you're looking for a place where it lines up with a corner. So if I had to guess, right here would be a point that lines up with the corner of a graph. So it's a nice point here. But again, I'll be a little bit lenient if you pick this point or this point. It's not technically on the graph, but I will take that because we're using Kami graphs. So if we're looking, this goes over 3 and up 2. So that point will be 3, 2. And then we're not completely done here because we know that it's not necessarily just points, that the points represent something. So the x term in all of our points are children. The y point is always going to be adults. So my first option that I'm listing is 6 children, 0 adults. The second option is going to be 0 children and 4 adults. And my last option is 3 children, 2 adults. So that's how we do question number 1.